All right, everybody. We're on lesson number 4 now. This is page 309. We're going to start to use our synthetic division and or long division. I am going to use synthetic division for all the examples that I do, but your choice. Synthetic division is a lot faster. Like I said before, you only need to know one. I would stick with synthetic division for this course. All right, so we're going to do a quick review. So we're going to use synthetic division, divide x cubed minus 2x minus 4 x squared minus 4 by x plus 1. So we'll do our little table here. So we got the number out front here. It's what makes this 0. Negative 1. Negative 1 goes out front. We use the coefficients of the polynomial here. But remember, because we don't have a bit here, we don't have a 0x, and they have to go down in descending order. We have to add that in. So we put the 1, the negative 2, it'd be a 0 for the 0x, and then minus 4 at the end. And bring down the first one. We multiply these two together. So I get negative 1. Then you always add negative 2 plus negative 1, negative 3. Negative 1 times negative 3 is positive 3. Add again, you get 3. Negative 1 times 3 is negative 3. Add them together and you get negative 7. That is my remainder. If you want the quotient, remember it's a cubic divided by a linear, so degree 1. So it would become x squared minus 3x is 3. All right. What happens if I put negative 1, p of negative 1, i.e. that is your x value, into this equation? Negative 1 cubed minus 2 times negative 1 squared minus 4. Remember to bracket everything, especially when you're putting in a negative, because negative 1 cubed is negative 1. Negative 1 squared is 1 times negative 2 is negative 2, and minus 4. Negative 1 minus 2, negative 3 minus 4, negative 7. What do you notice? It's the same as that. All right, and if you look, the number that we put in, negative 1, is the same as the number that was outside here. So essentially, this is our a value. It's an x value, so it goes in for x's. But remember, this is always written as x minus a. So that is our a value. So when you put your a value into the polynomial, you get the remainder, okay? So if you scroll down to here, that is essentially what this is. It's called the remainder theorem. If you're dividing by the binomial, x minus a, if you put a into the polynomial, you get the remainder. When a is plugged into the polynomial, it equals the remainder, and that will become important in this lesson. Okay, that's all you need to know from this page. So just a couple of examples here. We have x plus 1. Remember, everything is always x minus a. So this is actually x minus negative 1, because that's the way we get x plus 1. So this is our a value. A is equal to negative 1. That's why I always say what makes it 0, right, is your a value. Negative 1 in this case. So if I want to know the remainder, I just take negative 1 and I put it in for all my x's. Bracket it, especially if you are doing negatives. Negative 1 cubed is negative 1 times 6, so negative 6. Negative 1 squared is 1 times negative 4 is minus 4. Negative 1 times 8 is minus 8 plus 6. Negative 6 plus 6 cancel out. Negative 4 minus 8 is negative 12. That is the remainder. If you divide this by x plus 1, you'll get a remainder of negative 12, which you could do if you really want to. All right, what if it looks like this? Remember, this can be rewritten as, I'm put in equals because they're not equal, but they give you the same a value. Right? It's what makes this 0. In this case, that would be a is equal to a half. Okay? So I put 1/2 into this function, and I know nobody likes fractions, so you can do a decimal 0.5 if you want. I am going to do the fractions. So 1/2 cubed is 1/8. 1 cubed is 1, 2 cubed is 8. Minus 1/2 squared is 1/4. 8 times a half is 4 plus 6. 6 times 8 is, 6 over 8. These 4's will cancel, so you get minus 1 plus 10. If you combine all that together with a common denominator, you're going to get, well, negative 1 and 10 is going to be 9. And you can simplify this 6 over 8 to 3 over 4, or you could just find a common denominator. But either way, if you do it on your, you'll get 39 over 4. Now I'm not going to ask you to do fractional stuff, but just be aware that if you go on, obviously you're going to have to know fractional stuff. Whoa, sorry. So if you need to find the remainder, figure out what makes what you're dividing by equal to 0. That is your a value. Okay. And plug it into the function to see it. Let's do one more example. So, actually, we don't need to do any more examples for that stuff. Okay, we're gonna skip because I'm not gonna worry about this stuff. It's more just algebra. Normally we would do that if we were in class, but we're not. Okay, well, it's kind of blurry. Now the factor theorem. This is the important stuff. If you're, I'm just gonna summarize it. Whoa. Sorry, everybody, using the wrong your. If your remainder is equal to 0, then x minus a is a factor, i.e. you can start to factor this polynomial, and that's where this gets used all the time. So we're going to do polynomial we already know how to do. How to factor x squared plus 2x minus 24. We want to prove that this is one of the factors. Okay, so what is my a value here? A value is 4. And if your remainder equals 0, then x minus a is a factor. So if I put 4 in for your x's, 4 squared is 16, plus 8 minus 24. 16 and 8 is 24. This is 0. That shows that it is a factor. I think that is, we're going to read this down. It's faster. And if you, what they mean by factor is basically you can factor this polynomial. If I asked you to factor this polynomial, you would, if you remember your grade 10 and 11, What multiplies the negative 24 adds the 2? It's going to be x minus 4, x plus 6. So you can see that x minus 4 is a factor. Okay. So write a binomial factor. Binomial means two terms, such as x minus a. That's what they want you to write. With integral coefficients, whole numbers, no fractions. Of the polynomial if p of 3 is equal to 0. So we've said that p of 3 is equal to 0, which means the remainder is equal to 0. This is our a value. So the binomial factor is always x minus a, so it's x minus 3. That's it. This one, it's x minus, remember this is our a value, minus negative 2 over 3. Those negatives become positive. So you get this, but they want whole numbers, no fractions. So all you do is that 3 will go over there. You get 3x plus 2. That's it. Because this still gives an a value of negative 2/3. Okay. If p of 5 is equal to p of negative 2 is equal to 0, i.e. these are both factors, because the remainder equals 0, determine the second degree factor of the polynomial. Basically it means write out the polynomial. Well, my a value here is 5. My a value here is negative 2. So it's going to give me x minus 5, x minus negative 2, x minus 5, and x plus 2. That's it. Use the factor theorem to determine which of the following is a factor of this polynomial. Okay, so remember, if it's a factor, a will equal 0. So my a value here, negative 2. So I put that into the x's. I got 4 times negative 2 cubed times negative 2 squared minus negative 2 plus 4. Negative 2 cubed is negative 8. Negative 2 squared is 4. 4 times 16 is negative 64. Becomes plus 2. 8 and 4 is negative 32. Minus 64 plus 2 plus 4. That's going to give me negative 90. Therefore, 2 is not a factor. But what about the second one? You guys are going to love it because it's a fraction. So what's my a value here? It's going to be 1/2. Remember, if you want to know how to find your a value, set it equal to 0, is equal to 1, x is equal to 1/2. It's always what makes it 0. So I plug in 1/2. Again, you don't have to use fractions, you can use decimals. 1/2 squared is an 8th, or cubed, sorry, is an 8th. 1/2 squared is a 4. 4. 4 times an 8th is 4 over 8, which is 1/2. 16 times 1 is 16 divided by 4 is 4 minus a half plus 4. That half and that half cancel, that half, or that 4 and that 4 cancel. So the remainder is 0, therefore 2x minus 1 is a factor. And the last question for this lesson, this is a short lesson, so that 1 is a root of the equation, blah, blah, and find the other root. When they say root, I mean, alright, show that 1, that means our a value is 1. If they say the number, it is 1. So if it's a root, or it's a factor, then the remainder is 0. So for the P of 1, we'll go 1 minus 9 times 1 plus 20 times 1 minus 12. So it's going to be 1 minus 9 plus 20 minus 12. 1 minus 9 is negative 8. Negative 8 minus 12 is negative 20. So I get 0. Therefore, x minus 1 is a factor. Okay, the first part. Find the other roots. Find the other factors. And this is where this all comes together. To find the other factors, divide by x minus a. So we do synthetic division. Our a value, we're going to do is 1. We do the coefficients here. 1 minus 9, 20 minus 12. Now the 1, negative 9, and 1 is negative 8. Negative 8 gives me 12. 12. So I get 0, which is good. I got the remainder of 0, which matches this bit right there. And remember, this is a cubic. We're dividing by a linear, so we should get a square. So this is our quotient, which is going to be x squared minus 8x plus 12. We always write things, remember, in this class as dq plus r. So if I go d, what's my divisor? X minus 1, right? Quotient plus your remainder, which is 0. So you don't even have to write that. So you can see that I have x minus 1. Now, this is a quadratic, just like you learned in grade 11. In grade 10, you can factor this. So it's what multiplies to that and adds to this term. So what multiplies to 12 and adds negative 8 minus 6, x minus 2. And this is the factored form of this. That is a cubic function. So you've just factored a cubic function, which is actually a big deal. And that's where all this stuff gets used. It gets used to factor higher order. Up until this point, you've only been able to factor quadratics. But now we're going to start to factor cubics, quartics, you can do 5th degree, 6th degree, etc., all the way up. All right. The only questions I would like you to do are number 1, number 7, and number 11. All right. Please email if you have any questions. Thank you.